Hi everyone, today we're going to look at when an object is both moving translationally and rotationally with respect to forces. So for this situation it's a yo-yo, and we know that we have that inner solid spool within the yo-yo, and then the outer edge, as it falls along the string will unwind and the yo-yo center of mass will go straight down. But there is that string that still has a tension up that prevents it from falling at the rate of gravity. So with most force type problems, we're going to have to identify what the forces are, use a free body diagram, and write out our equations, right? So on the yo-yo at the center of mass, it does have mg, but there's also a tension upwards on the string. So for a translational force equation, we just have mg minus tension, making the direction of acceleration positive. Now if we look rotationally, we have one torque about the center of mass, and it's the tension that causes the torque. Now, I saw on the last WebAssign that some of us are still setting the tension equal to mg, even though the object is accelerating. Always ask yourself, is the sum of all torques accelerating or equal to 0? Same thing with the linear forces. If it's not 0, the tension can never equal mg. Or else, in this equation that we have, if these two equal each other, that's 0, and it's not moving, or it's moving at a constant speed. So we have one torque, and that is caused by the tension acting at the small radius from the center. Now, the combination of these is still that very similar process that we used in the last chapter, where we can substitute that alpha is equal to a over r. Now for this general solution, we're going to solve for the linear acceleration first. Again, it's a general solution. It's very similar to what we just did in the last chapter for a couple problems, and then it's basically the same process for coupled motion. Okay, so we make this substitution into here. And we can combine the r's on the other side. The next step in this type of problem is to add the two equations together. All right, so we can get the linear acceleration in relationship to each other. So we end up with mg. These cancel. So you put ma plus ia over r squared. All right, just separate that from the other two right now. Now we just have a little bit of manipulation to get the a by itself. If we factor out the a, we have m plus I over r squared. Just move that on over. Now we're going to see this relationship pop up whenever it's even on a ramp. So we're gonna reference this later. So this was a short video, but we're gonna reference this in the next one, where it's gonna be forces with rolling.